Okay, so this is discrete probability distributions chapter 4. We're going to give a few definitions, guys, before we get started, and I'll ask you to help me as well once I give you the definitions to help me come up with more examples. Okay, what is a random variable? Variable means it changes. A random variable represents a numerical value associated with each outcome of a probability distribution. It's usually called X. Probably from algebra, this is the only thing that you're going to do, just know about X and Y. Example, number of sales calls a salesperson make in one day. Do you guys agree that this is a variable because it changes? The salesperson in one day could make 10 calls, another day make 15, a third day make no calls. So this is a variable. Hours spent on sales calls in one day. How many hours the salesperson spent on making phone calls, like those mortgage people, for example, want to sell mortgage. These hours vary. That's why it's called X. Can you guys give me some more examples with a random for a random variable? Yes. X is, what would you guys say? Numbers of hours a student study a day. You can come up with too many examples. Let me come up with one more. D. Miles driven each day. You know, this is a variable. It's not going to be exactly the same every day, so it is a variable. Now, let me tell you what a discrete random variable is. A discrete random variable is a random variable, but it has a finite or a countable number of possible outcomes. So that means X has to be 0, 1, 2, 3, 4, 5. It can't be a decimal. So it has to be a whole number, and we can count it, you know, just on our fingers, just like 1, 2, 3, 4, 5. For example, X is the number of sales calls a salesperson make in one day. The salesperson can count the number of calls he or she makes a day. They either 0 calls or 1 call or 2 calls or 3 calls or 4. So it has to be a whole number. Can someone think of another example for B? Yes.
The number of items on a shopping list.
Yes. Number of items on the shopping list. The shopping list could be empty, 0 items or 1 item or 2 items or 3 items or 4 items. That is discrete. And this chapter, guys, is about discrete, so variables. So we're only dealing with variables that we can count as 0, 1, 2, 3, 4, 5, etc. Now, let me tell you what a continuous random variable. We will not use continuous random variable in this chapter. It will be in chapter 5, but we need to do the definition. A continuous random variable has an uncountable number of possible outcomes. That means you cannot count them like 0, 1, 2, 3, 4, 5, 6. It is represented by an interval on the number line. Usually it is a measurement, guys. All measurements are not countable for your information. For example, X is the weight of a person. Weight of a person is not countable, meaning if one person is 160 pounds, does it mean that the next person who is a little bit heavier than that one is going to be 161 and the next one will be 162? Do you guys agree that there could be decimals there? even if someone is 160 pounds, it doesn't mean that this person is exactly 160 pounds, probably because the scale is rounded to show the whole digit, whole numbers, so it will not show decimals. So anything that has to do with measurement, guys, is not countable. Amount of gas in the car, that is not countable, so that is continuous. Volume of gas. I'll put some more. Height of a person. That is continuous. So anything, guys, that you use a tool to measure, it's not countable. You can think of it as a continuous random variable. Temperature. Even if they list them as whole numbers, they say 72, 73, 74. But it doesn't mean that if the temperature is 72, the next one, which is a little bit warmer, is 73. It could be 72.3, but we do round them. So because they're measured using a thermometer, these are continuous. The only thing that is discrete is what you can count as 1, 2, 3, 4, 5, 6, etc. So let's try some more together. What do you think of, you try it, the number of Fortune 500 companies that lost money in the previous year? Is it discrete or continuous? What do you guys think?
Continuous.
What number of companies, can't you count them as either zero company who lost money or one company? Discrete.
Yeah.
You can't have 1.5 company. If you can have a decimal, then it is continuous. If you can't have decimal, then it is discrete. Discrete. And X, guys, can be as low as 0 or as high as 500. So X could be 0, possible values of X, 0 or one company or two, up to 500, because these are Fortune 500 companies. What about the volume of gasoline, guys, in a 21-gallon tank? Once I mention volume, guys, you're done. This is continuous. It can't be. It's a quantity. Yeah, it's continuous. Okay, let me add one more. X is number of students present today.
Discrete.
Yep. That is discrete. And if you want to know what X could be as low as 0 all the way to the number of students that I have on my roster, probably 27. So it can be as low as 0. Hopefully it's not 0. So that means nobody attended. And also it is hopeful to get everybody to attend. So 27, it's between 0 and 27. That is what discrete, that is what continuous. So that's very, very important, guys, to distinguish between the two, continuous and discrete. Now, let me tell you what a probability distribution is, and we're going to do an example. We call a probability distribution a discrete probability distribution if it meets two conditions. And I will show you an example to understand this. Each probability, if you have a table that lists probability, each probability must be between 0 and 1, and the sum of all probabilities must be 100%, which is 1. 100% means 1. Let me give you an example here. Okay. Let's look at this example, and then I'll explain probability distribution from this example. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Individuals were given a score from 1 to 5, where 1 was extremely passive and 5 extremely aggressive. A score of 3 indicated neither trait, nor passive nor aggressive. Construct a probability distribution for the random variable X, then graph the distribution using a histogram. Okay. Let me ask you a few questions. You have this table, guys, and you learned about empirical probability in chapter 3. If I ask you, what is the probability of selecting an employee who had a score of 1? How would you figure this out from the table? So what is the probability that someone was selected has a score of 1?
Is it 24 over 150?
Exactly. So right here, guys, probability of 1, it's going to be 24 divided by 150. Very good. Now, if I ask you guys, what is the probability of selecting an employee who had a score of 2? Would you guys agree with me that it should be 33 over 150? If students are asking about the 150, it's the total of all frequencies, which he says it's 150 employees. 3, guys, it's going to be 42 over 150. And 4 is going to be 30 over 150. And 5 is going to be 21 over 150. Let me just calculate those numbers, and then I'll put them. I'm using now the older calculator, just so to show you that we can do the math also on this calculator as well. So I got 0.16. Now 33 over 150. 22%. 42 over 150. 28%. 30 over 150 is 20%. And 21 over 150 is 14%. Okay. Let me show you how to construct a probability distribution, guys. It's very easy. You put the score here, which is X. And instead of putting frequency, which I put F, put P of X. P of X stands for probability of X. And you put 1, 2, 3, 4, 5. And instead of putting the frequencies, guys, here, you put the relative frequencies, which are the probabilities. So that will be 0.16, 0.22, 0.28, 0.20, and 0.14. This is called a discrete probability distribution table. Do you guys agree with me that each probability is between 0 and 1, as you notice? They are all must be between 0 and 1. That's condition number 1. But what do you think if I add them, guys? What should I get here? (0.16 plus 0.22 plus 0.28 plus 0.20 plus 0.14. I don't need to add them because I know what the answer is going to be. It's going to be always 1. If you don't get 1, if I give you an example, let's say on the test, and I ask you, does this represent a probability distribution? If you add them and you don't get 1, that means it's not a probability distribution. A valid probability distribution, all the frequencies, the relative frequencies must add up to 1. So a probability, guys, is a relative frequency. Just add them up, you should get 1, and each probability, as you can see, it's between 0 and 1. Let me give you an example now to check whether we understand what a probability distribution is. I'd like you to look at this example and tell me, guys, if you think that this is a probability distribution or not. Well, you know, this is the example we just did. Do you agree with me, guys, that each probability is between 0 and 1? You can see they're all, and if you add them up, we just did it above, so it's the same example, you get 1. So the answer is yes. It is a probability distribution. Let's do another example. If I have one here. We'll do some from the book. Okay. Any questions about the probability distribution? Okay, before I continue, I go further, I'm just going to do a couple examples from the book. So just to make sure, guys, that you understand this. If you have a question with the table and you're asked to verify whether this is a probability distribution or not, you check and make sure that each probability is between 0 and 1, and you add the probability and you make sure it is 1. If it's not 1, then it's not a probability distribution. Now, the other question you might have is to find the mean of the probability distribution. And I'm going to show you through this example how to find the mean of the probability distribution. Here is how you do it. And I will show you how to use the calculator to do such a thing. Here's the formula to find the mean. Does anyone know how to interpret this formula if I want to use it? It says sum of x times px. Any idea how do I get started if I want to do this by hand?
You start with 1 times 0.16.
Exactly. 1 times p of 1 plus 2 times p of 2 plus 3 times p of 3 plus 4 times p of 4 plus 5 times p of 5. But you will be happy later to find out that this can be done on the calculator. 2 times 0.22 plus 3 times 0.28 plus 4 times 0.2 plus 5 times 0.14. And then we do the math and we figure this out. Now, let me show you how this could have been done on the calculator, and then we'll get the answer from the calculator. Watch. You need to enter the data into L1, the X values, and the PX values in L2, the probability values. So we'll go to Stat, Edit. I'm gonna clear this one. And I'm just gonna put 1, 2, 3, 4, 5. Then guys, you go to the next one, L2, and put the P of X values. If you have your calculator, guys, I'm just gonna pause for a second so you can enter this stuff. So 0.16. Be careful as you enter the decimal. 0.22, 0.28, 0.20, 0.14. Okay, watch how we find the mean. You go to Stat, Calc, one variable statistic. Okay. If you have the newer calculator, it's going to give you a menu and it says the values in L1, and for frequency, the next one you have to put L2. But look how you do it here on this one. You put second, 1, comma, second, 2. So you're telling the calculator, I have the X values in L1, but the frequencies are in L2. And press enter, guys. And the mean is 2.94. It's the first value. .94. So again, guys, to do this,
to do this by hand. You go to Stat, Edit, L1 and L2, you put the values in L2, then you go to Stat one more time, Calc, one variable statistic. If you have the newer calculator, make sure that the first line has L1 and the second line has L2, and then calculate. This is how you find the mean. Now, how do you find the standard deviation? Well, guys, it's already done for you right here. Sigma is 1.27. So this is the standard deviation of the probability distribution using the calculator, which we'll come to this next. It says variance of the discrete probability distribution. There is a formula, guys, but I'm gonna allow you to use the calculator. So for this one, it's gonna be 1.27. The calculator doesn't give the variance. So once you find the standard deviation, you just square it here. So that will be 1.27 squared. So I would learn how to do the mean by hand, but it's not necessary to know how to do the standard deviation and the variance by hand. It's a lot of work. But the mean, sometimes it is faster to do it by hand. Any questions, guys? And all the information on how to use the calculator is given here in the handout. Find the standard deviation. You can use your TI-84 calculator. Input the X values in L1, input the PX values in L2, and do the following. So if you guys forget how to use the calculator, you can go back and reference this handout to figure out how to find the mean and the standard deviation. Any questions? All right. Let's move on to the expected value of a random variable. The expected value of a discrete random variable is the same as the mean, but I'm going to show you what this is using an example. It's an interesting thing in discrete probability. So just 1 second, let me move to the next one. And let's show you how this is done. Okay, guys, at a raffle, you have 1,500 tickets are sold at $2 each, and there are 4 prizes. So there are 4 numbers that are winning numbers out of the 1,500. You buy 1 ticket, what's the expected value of your gain? So if you gain, how much you're gonna gain, what's the likelihood that you're gonna gain? We're gonna show you how to find this out using probability distribution. For your information, guys, for Las Vegas, it's all about gambling. And there are machines built in there for gambling. Just for your information, before even you get to know what the expected value is. The expected value for any machine in Las Vegas is negative. That means they build it based on the fact that eventually the person is gonna lose. If the expected value was positive for any game, so people would just go play and keep winning. It's not even 0, it's below 0, and you will see that in a second. And even for this one, a raffle ticket, it's built so you end up losing. Only 4 winning tickets, but the rest of the tickets are gonna be losing tickets. And let me explain this to you. Okay, guys, you spend money to play. How much does the ticket cost? It's $2, but that's not a gain, guys. Once you pay the $2, it's a loss. So how do you think I should represent the X here? How do the $2? How do I put this? Any ideas, guys? Any feedback? For X, this is a money that you don't have anymore once you pay the $2. Negative 2, exactly. Okay. What is the probability of losing now? So you're gonna lose this $2. Once you put $2, what's the probability of losing? Anyone can help me out? It's a denominator here. How many tickets do we have? 1,500 tickets. How many tickets are losing tickets? There are only 4 winning. 1, 2, 3, 4. So the rest of them, you're going to end up losing. So it's 1496 divided by 1,500. Why 1496 divided by 1,500? Because there are only 4 tickets that winning tickets, and the rest of them you won't win anything. So that's why it's 1496. If you win the 500, guys, how much? Let's go to the next one. If you win the 500, how much money do you gain? Can someone tell me? You already paid $2. Remember, you already paid $2. So how much money do you gain? Not do you get, do you gain?
$498.
Exactly. You're only gaining $498 because you're going to get to your $2 back. So you're gaining $498. And what's the chance of this happening? There's only one winning ticket. It's 1 over 1,500. Okay, let's go to the next prize. If you win $250, guys, they'll give you $250, but you already paid $2. So you're gaining only 248. And your chance is only 1 out of 1,500. For 150, you're only gaining 148 because you're getting your $2 back. And then 75, it's going to be 73, guys, and 1 over 1,500. The expected value is the same as the mean, which is sum of x, p of x. I'm going to write it down and give you a chance, guys, to do the calculation with me. Plus 248 times 1 over 1,500 plus 148 over 1,500 plus 73 times 1 over 1,500. Okay. Can you guys do the calculation? Just want you to use your calculator and do the calculation for a second. So the answer is negative 1.35. It means, guys, so please pay attention to this. You are expected to lose $1.35 for each ticket you buy. You see, the expectation is a loss, not gain, never gain. Because if it is gain, everybody would gain and everybody would make money, but it's always a loss. So that's what the expected value. Again, guys, the expected value, if I ask you to find the expected value, is exactly the same as the mean. You just find the mean. But the interpretation is slightly different. Okay, that concludes section 4.1. We're going to go to section 4.2 now. That's it. That's all you need to know in section 4.1. What is a probability distribution? Each probability has to be between 0 and 1, and some probability is equal to 1. How do you find the mean? How do you find the standard deviation, expected value of probability distribution? And how can you tell if a variable is discrete or continuous? We're going to go to the next section, which is going to be heavily done on the calculator, which is called the binomial probability. You can get for 1496, probably made a mistake somewhere. It should be negative 1.35. All right, guys. Binomial probability distribution. We say that a probability distribution is binomial if it meets the following conditions. And then I will give you an examples, guys, to understand it. If you do an experiment a fixed number of times, for example, roll a die 10 times, you just do it only for 10 times. That's called a fixed number of trials. So that's condition number 1. you have only two possible outcomes. One is called a success and one is called a failure. For example, you roll a die, you would win if you get a 5. So if you get a 5, you win, it's a success. And if you don't get a 5, you fail, it's a failure. The probability of success does not change from one roll to another. What is the probability of rolling a 5, guys, on a single die? It's 1 out of 6. Does this change if I roll a die second time and third time, fourth time? No, it's always 1 over 6. So that's another condition here you have to meet in order to have a binomial distribution. And the random variable x is the number of successful trials. They call the number of trials n. They call the probability of success p, and the probability of failure is q. And the relationship, guys, between p and q, it's p plus q equals to 1. Probability of success plus probability of failure is always equal to 1. For example, the chance of rain today is 70%. The chance of no rain is 30%. If you add them up, you should get a 100%. So this is what a binomial distribution is. It has to satisfy those 3 conditions in order to say that an experiment is a binomial experiment. And I'm going to give you some example and verify that those conditions are met in a second. Okay, let's look at this. A certain surgical procedure has an 85% chance of success. So that's a probability of success, guys. It's 85%. A doctor performed the procedures on 8 patients. The random variable represents the number of successful surgeries. What do you guys think? Is this a binomial experiment? Yes or no? Are we doing it a fixed number of times? The answer is yes. Okay, fixed number of trials. And I'll write the number. It's 8 because he's doing the surgery on 8 patients. 2, what is the probability of success, guys, of the surgery? They said it's 85%. So that is 0.85. What's the probability of failure? 0.15. If you ask me where did I come up with the 0.15, it's 100% minus 85%, which is 15%. So this condition is verified. The probability of success is always the same, doesn't change from one outcome to another. So this is a binomial experiment. Now, what are the possible value of x? X is the number of successful surgeries. Can you guys give me the lowest value of x? What could x be as low as what? X is the number of successful surgeries. He's performing surgery on 8 patients. What are the possible values of x?
1.
It could be below 1. It is, I mean, it's very unlikely to happen, but the doctor, it could be none of the surgeries are successful. But the chance for this happening, guys, is very, very low. And then it could be 1, it could be 2, it could be 3, it could be 4, all the way up to 8. So guys, X is the number of successes. And for your information, X always starts with the 0 and end with the number of fixed trials, which is 8 in our case. So it could be as low as 0, as high as 8. I'm not saying that the doctor is going to perform 8 surgeries and get 0 success. No, that's the probability is going to be very low. It's just like winning the lottery here. But it is possible. It's not 0, so that's why you have to include it. Let's go to number 2 and tell me, guys, if you think that this is a binomial experiment. A jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles, so n is 3. That's good. We have fixed number of trials. Without replacement, that means once you select the first marble, you don't put it back. The random variable represents the number of red marbles. Okay. If you do it 3 times the number of red marbles, you could get 0 marbles in the 3 trials, or you could get 1, or you could get 2, or you could get 3. But does the probability of success, guys, getting a red marble change from one marble to another? You draw the first marble. When you get the first marble, guys, what's the probability of getting red? Can you help me? What is the probability of getting a red marble? I have a total of 5 out of what? 5, 9, 14, and 6, 20. Now on the second marble, guys, what's the probability of red? Remember, it's without replacement.
5 out of 19.
4 out of 20.
4 out of 19. Exactly. So it's 4 out of, did it change from one trial to another? It did. Once that changes, guys, you don't have a binomial experiment. You don't have a binomial experiment because a condition of the binomial experiment, the probability of success should not change from one trial to another. Whereas for the surgeon, it says, regardless of the patient, the probability of success is always an 85%. Okay, so this is what a binomial experiment. Now get your calculator ready, guys. We're gonna show you how to perform binomial probability calculations using your calculator. So a binomial experiment, again, guys, he has to give you a fixed number of trials and he has to give you a probability of success. Once he gives you that and tell you you have a binomial experiment, you can answer questions pertaining to binomial experiment. And we're gonna show you some examples here. All right. This is an example. Microfracture knee surgery has 75% chance of success. So P is 75%. What is the Q, guys? Q is the probability of failure. Can someone help me here?
25.
25%. Let's write them as decimals. All right. Chance of success on patient with degenerative knees. The surgery is performed on 3 patients, fixed number of trials, guys. So N is 3. That's good. It is a binomial experiment, guys, because the probability of success does not change. He didn't say it will change, so it's 75%. We have a fixed number of trials, so that's it. That's all we need. Find the probability that the surgery being successful on exactly 2 patients. So he wants the probability of the number of success being only 2. So what is the probability if the surgery is performed on 3 patients, only exactly 2 surgeries will be successful? We have 3 patients here, guys. Let's show you a picture here. Okay. Patient 1, patient 2, and patient 3. He says, what's the probability that 2 of the surgery are successful, but he didn't specify which patients. So it could be 1, 2 have successful surgeries and 3 not. Or it could be 1 and 3 had successful surgery, but 2 didn't. Or it could be 2 and 3 had successful surgeries, but 1 didn't. Do you agree, guys, with this scenario? It could be any 2 of the 3. So there are so many possible scenarios. There is a formula, guys, that can take care of all those scenarios. I'm going to do it by hand, but then after that, I'm going to take you to the calculator and show you how this is done using the calculator. So for the sake of, this is the formula that is built in your calculator. So I'll show you how to use this one, and then we'll proceed to the calculator to find probability of X equals 2. Okay, we need X to be 2 here. The formula says N choose X, which we did in chapter 3, guys, My n now here is 3 and my x is 2. So there will be 3, choose 2. You learned how to find the combination in 2. P is 0.75 raised to the power of 2. Q is 0.25 raised to the power of n minus x. And this is the formula. This is the combination formula that we did. And I'm going to show you how to compute this by hand, but you guys, you can use the calculator later. I just feel that I should verify the formula before I move to the calculator. So n is 3, guys. X is 2. P is 0.75 and Q is 0.25. So to use the formula, you put 3, choose 2, then you put 0.75 raised to the power of 2, and the Q, guys, is the failure, so it will be 0.25, n minus x. What's n minus x, guys? A 3 minus 2. Okay, let's use the calculator by hand first, and then we'll go to the program on the calculator that will take care of this. So you do 3, math, and then you go to probability. Oops, sorry. And then NCR 2. You get 3 times 0.75 raised to the power of 2 times 0.25 raised to the power of 3 minus 2, guys, which is 1. And here's the answer. If I want to do it to 3 decimal places, it will be 0.422. So the probability that the surgeon perform a surgery on 3 patients and only exactly 2 out of the 3 has a successful surgery, it will be 0.422. This is using the formula by hand. Now let me show you guys how you could have done this using your calculator programs. So anytime, guys, he asks you to find the probability of exactly a number, this is how you proceed using your calculator. So please pay attention to this, and I'm going to show you how you could have done this in one shot using the calculator. You go to second and distribute. Second and distribute. Then you go scroll down until you see binomial PDF. Binom means binomial PDF, probability density function. Okay. If you have the newer calculator, it's going to ask you to enter the value of trials n and then p and then x. Well, if you have this calculator, guys, you will have to enter them but separate them with the comma. What is n, guys? What's n? 3, correct? Comma. What is p? 0.75. Comma. What is x? He's asking us to find probability of x equals 2. We should just put 2 here and watch, guys. It's going to be like magic. 0.422. So you need n, you need p, you need x, and the binomial PDF is only reserved for exactly. So you just use this formula when you do probability of x is exactly a certain value. Any questions here? No questions? Let me see if anything in the chat. Is that clear to people and how to use this formula? We're going to do some more, but this is how you demonstrate that using your calculator. All right. Let's go to the next page. Using TI-84. I need your help, guys. You're gonna participate with me on this one. With this exercise, guys, I'm just gonna wrap up the section. There are a few other things to do, and we'll be done with chapter 4 after I finish this example. All right. The results of a survey indicate that 67%, what do you guys think the 67% is called here? What letter? N, P, Q, X. Let's see here what we have. P, very good. Consider air conditioning a necessity. If you randomly select 10 adults, who's gonna tell me what 10 is? No, not X. N, yes. X will be in the question. So N is 10. The bigger number is N, guys, and the P is 0.67. Actually, guys, you don't need a Q because when you use your program on the calculator, it doesn't require that you use a Q. Okay. First question. What's the probability that exactly 7 of them consider air conditioning a necessity? You start like this, guys. Probability of X equals 7 equals. And then we're gonna go to Binompdf. We're gonna enter the value of N, we're gonna enter the value of P, and we're gonna enter the value of X. My N, guys, is 10. My P, these two values do not change at all, 6, 7. And my X in this case is what? 7. And let me show you how to do this. So you go second, distribute. You scroll down. Binompdf, sorry, it's right here. And now you put N, which is 10, comma, P, which is 0.67. Don't mix them up. N comes first. And then X is 7. And here you go. 0.26, let's see, 3 decimal places, 0.261. A question for you guys. What about if he says, what's a probability that none of them consider air conditioning a necessity? What would you change in here? Waiting for a response. No, not that. Not 1 minus. You need to change the value of X and then do the calculation. What is the probability that none of them consider air conditioning a necessity? What would X be? That's what I'm asking.
Would it be 1 minus 0.67?
No. You need to change the value of X. What does it mean exactly? None of them. X is what? Guys, you know X, as I told you, starts as low as 0 and goes all the way to 10. When I say none of them consider air conditioning a necessity, X is 0. It just puts 0. And let me, yes, let me answer this question. If I ask you this question, you just do this. Second, distribute, and then, okay, so you put 10, comma, 0.67. 0.67 never changes, guys. It's always, it has to be there, 0. Okay, it will be 1.5315 E negative 5. Do you guys understand what E negative 5 means? E negative 5 means that you have to move the decimal point 5 digits to the left. So actually your answer is 0.000015. It's almost 0. That means, guys, if you interview 10 adults it's very, very unlikely that all of them, they're gonna see that air condition is, that none of them, they're gonna say air condition is necessity. At least one or two are gonna say it is a necessity. That's why the probability is very low. What about if they ask you what's the probability that all of them consider air conditioning a necessity? What would X be? That's a possible question on the next test. What's the probability that all of them consider air conditioning a necessity? When I say all of them, that means X equals what, guys? 10. Exactly. And let me show you how to do it. You just go to second and distribute. Binomial PDF. It's going to be a low probability as well. So n is 10, comma, 0.67, comma, 10. There you go. 0.018, which is higher than the other one. So about a 2% chance that all of them are gonna say air conditioning is necessity. That means, guys, if you interview 10 people, don't expect all of them, you know, just to say that air conditioning is necessity, because the chance that this happening is only 2%, 1.8%. Okay, so the binomial PDF, this is what I'm trying to say, guys. The binomial PDF is reserved only for questions that have the word exactly. So when you see this word right here, you guys right away know that you must use this formula. Now let's go to the next one. What is the probability that at most 7 adults consider air conditioning a necessity? Now for at most, guys, do you know what sign, what inequality do we use for at most? I'm gonna write the inequalities for you. At most, guys, means less than or equal to. Which is this sign. And at least, for your information, guys, it's this sign. At least. Okay. So the probability that at most 7 adults, you write it like this. Okay. What does at most 7 adults mean? So it could be 7, it could be 6, less than or equal to 7. 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. Does anyone have an idea how to find this one? Using part A. For example, if we have no tools but what we learned in part A, how could I do probability of X less than or equal to 7? As I said, probability of X less or equal to 7 could be probability of 7 or 6 or 5 or 3 or 2 or 1 or 0. Any ideas? There's a long way to do it, which we're not going to do it, but I expect one of you to tell me about it. No, this is the probability. 0.261 is the probability of exactly 7. Now we want 7 or less. So 7 is good, 6 is good, 5 is good, 3 is good, 2 is good, 1 is good, 0 is good. How would you do it using binomial PDF? How would you solve this problem? That's not difficult, guys. If this is the tool that you have, you could use this tool to answer this, but it will be long, a lot of calculation. What would you do?
So like for X, would you plug in all the numbers? Like
Exactly, but we're not gonna do that. Look, this is how you can do it. You plug in 7, you get 0.261. You plug in 6, you get something else. You plug in 5, you get something else. You plug in 4, 3, and since it's an OR, guys, you learned in chapter 3 that OR means addition. You add them up. It's a lot of work, guys, because if this was X less than 17, for example, 17, you have to do 17, 16, 15, 14, all the way to 1. That's one way to 0. So this is one way to do it, but I'm not going to recommend that you do this. The good news, guys, that the calculator has a built-in formula for at most. So for at most, the calculator has a built-in formula. Any questions before I go to this formula?
Yeah, before you start, did you mean to skip 4?
No, I didn't. Oh, I did skip
Okay.
it. You're right. There you go. 4 is there. No, I didn't. So to do it, guys, using the tool that you learned in part A, you have to do, as you said, binomial PDF, change X to 7, change X to 6, change X to 5, change it to 4, change it to 3, change it to 2, to 1, to 0, and do it, 8 times, add them up, you get the answer. And be honest with you, I've had some students in the past, just doing it this way. But wouldn't you like, just to see that one formula that can take all of this? And that formula, guys, is only valid if you have at most. So please pay attention to this. It's only for at most. Here is the formula. It is called not binom PDF. It's called binomial CDF. CDF means cumulative. It is, you put N and you put P and you put X. So it's going to be, and I'll go to the formula in a second. N, guys, is 10. P is 0.67 and X is 7. But remember, you're not doing a PDF, you're doing a CDF, because some students will tell me we did it already in part A. In part A, we use the PDF formula to find only exactly equal to. Here, we're doing at most. And watch, guys. So what the calculator is going to do, it's going to find the probability of X equals 7. Then it's going to do 6, 5, 4, 3, 2, 1, 0. Add them up without us noticing. All in one shot. Watch. Second, distribute. And binomial CDF. You see, these are the only 2 formulas that you use in section 2. PDF or CDF. Okay. So put 10, comma, 0.67, comma, and 7. There you go. The answer is 0.693. Any questions? So guys, for exactly, you use binomial PDF. For at most, you use binomial CDF. Please take a good, careful note about this. Any questions? Okay, let me go to the next question. We'll just do C, and then the last part, and that should be it. What's the probability that more than 7 adults consider air conditioning a necessity? Who can tell me how to write more than 7? So what would be the sign? Probability of X. What sign do I put here, guys?
Greater than?
Greater than 7. Okay. Greater than 7, guys, would you agree with me that what is greater than 7 up to 10? What are the numbers that are greater than 7?
8, 9, and 10.
Or 9 or 10. Okay. Look, this is how you can do this one if you want. You can do a PDF on 8, PDF on 9, and PDF on 10 and add them up. That's one way. That's one way to do it. But the problem is, guys, if you have so many, then you're going to have to do each one and then add them up. The only 2 tools that you have here is the binomial PDF and the binomial CDF. Any ideas, guys, and how we can make use of the binomial CDF to answer this question? Although the binomial CDF is only reserved for at most. Any ideas? I'd like you to think about it for a few seconds. And please participate with me. I will assist you, even if you say something that is not correct. Any ideas? The only 2 formulas that you have, guys, is the PDF and the CDF. And the CDF is only good for less than or equals. Here, I don't have less or equal, I have a greater than. But there is a way, guys, that you can still use one of the formulas. As I said, you can do PDF on 8, PDF on 9, PDF on 10, and then get the answer, add them up. There are not too many, but I'm gonna show you a shortcut to this. No normal, we're not using normal yet. Normal is for chapter 5. Okay, any good suggestions will earn an additional 2% on the next test. There you go. Probably that will motivate you. You guys, watch. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what we always have. As I told you, we always begin with as low as 0, and we end with the size of the sample, 10. He wants 8, 9, 10. That's what he wants. Do you guys agree that this is what we need to get, 8, 9, or 10? The formulas in the book and the calculator built in the calculator does not allow us to do that. But look what we can do. This is a workaround. Can I find this? Do you think, guys, I can find the probability of X being 7 or less? Yes or no? This way you always can find, this is at most. We can do probability of X less than or equal to 7. Which you already did, guys, in part B.
So are we going to do 1 minus the probability?
Exactly. You got it. 693. You already did this, guys, in part B, which is 7 or less, but that's not what I want. But you guys know that the sum of probabilities must be equal to 1. So if this is, guys, 0.693, how much is left, just for this one? As you said, it's 1 minus 0.693. And that's going to be the answer, which is 0.707. So this is a way to work around. If you have a greater than, guys, you cannot do it using the calculator right away. So you have to do the less than and then do 1 minus. But you could have done a PDF on 8, PDF on 9, and PDF on 10. Add them up. They will just give you, sorry, that's not 7307. They will give you the exact same answer. If that's okay, guys, I just need a couple more minutes. I know we're almost out of time. Just a couple more minutes, and then we'll continue tomorrow. I'm going to skip D. I'll revisit tomorrow. I'm just going to show you how to find the mean and standard deviation of the binomial distribution, which is an easy part. The mean of the binomial distribution, guys, is simply n times p. And n times p, n is 10, p is 0.67. You just multiply them and you get 6.7. So it's as simple as that. There is no calculator program for the mean of the binomial distribution because it's so simple to do. So you can do it, by hand. The standard deviation, guys, is also very simple. It's a square root of npq, which is square root of n, 10. P is 0.67. And Q, guys, Q is the probability of failure. So if P is 0.67, you agree with me that Q is 1 minus 0.63. Yep. And let's do it. Please work with me when I do something so then you guys can get used to it when you do the actual thing. So I'm going to do this with you, show you how to calculate that. So 10 times 0.67 times 0.33. And then you need to square root it. Look, how do I square root, guys? You don't need the radical sign. Just raise it and put 0.5. And that's 1.49. So this is the standard deviation of the binomial distribution. And this is the mean of the binomial distribution. What we will do tomorrow, so I guess we didn't finish the whole thing today. I will do another exercise with chapter 4, and I'll do the part, probably guys, for tomorrow, just to come prepared. At least 7 means greater or equal to 7. Why don't you try to figure this out and tell me how you can work around this one tomorrow using the binomial CDF? How could you have done that using, you know, the binomial CDF formula? We'll talk about it tomorrow. All right? Okay, that's it.
Thank you.